Since the beginning of time, people have been trying to understand our universe. Over the course of history, we have gained more understanding, and theories and models have developed in an attempt to explain what everything is made of. Our current model explaining what the universe is made of is known as the Standard Model. The Standard Model is a set of rules that describe the interactions of the fundamental particles of quarks and leptons. It also describes the interactions of the force carriers for the electromagnetic force, the strong nuclear force, and the weak nuclear force. But the Standard Model leaves out one very important force: gravity. Mathematically, gravity simply doesn't fit within the rules of the Standard Model. While the Standard Model is able to give us a better understanding of fundamental particles, it isn't complete. It is unable to fully and accurately describe the way fundamental particles interact. This incompleteness has led scientists to continue searching for one model, one theory, that explains the basic fundamental workings of our universe in a unified, consistent, and complete way. In the 1960s, theorists developed a theory called string theory. Initially, this theory had major inconsistencies and problems, but over time it developed into one of the leading theories that attempts to explain fundamental particles in a unified, consistent, and complete way. Since string theory is explaining fundamental particles, it has become known as the theory of everything. String theory has multiple variations, break-off, and sub-theories, which can make it seem really confusing and hard to understand. Also, as the theory of everything, there's a lot it is trying to explain, which can make it seem complicated. But the core idea of string theory, which is the foundation of the theory and what the theory essentially is pretty simple. According to string theory, all the fundamental particles and forces are actually made up of tiny, vibrating, one-dimensional strings that are so small we can't see them. This means that if we can microscopically zoom in on an electron, instead of seeing the point-like particle of an electron, we would see a tiny vibrating string that creates the electron. Just like the strings of a guitar vibrate in different ways to create different notes, each string in the theory vibrates in a different way to create each different particle. For example, a string vibrating like this would create an up quark, whereas a string vibrating like this would create a down quark. There are two different types of strings: open strings and closed strings. Closed strings are what convey gravity, and they can vibrate on their own. But open strings, which create all the other particles, have to be connected to another fundamental object called a brane, which is short for membrane. Branes are often seen as two-dimensional sheets, but they can be many different dimensions and have mass and charge. String theory suggests that our universe exists on a giant three-dimensional brane that the open strings are anchored to. Another important aspect of string theory is that in order for the theory to work, there have to be 11 different dimensions. This doesn't seem possible since we only see and experience 3 dimensions: forward and back, side to side, and up and down. But scientists think that the extra dimensions are just so small that we can't see them. For example, if we look at this piece of string from far away, it looks one-dimensional, but close up we can see that it's actually 3-dimensional. This same idea applies to the extra dimensions. The extra dimensions are so small and curled up that we can't see them, but in theory, if we had the ability to see small enough, we would be able to see them. It is through these strings, branes, and extra dimensions that string theory attempts to explain the building blocks of our universe in a unified and complete way. One of the appealing things about string theory is that gravity and its ability to move around without being confined to a brane is essential to the theory, because in past theories, gravity didn't even fit. But the problem with string theory is that everything is so small that we currently don't have the ability to prove whether or not it is a correct theory. Someday we may discover that this is the theory scientists have been looking for, the one and only theory of everything. But we may also find that it was all for nothing, that the theory just won't work, and it will fade into the history of science as another attempt to find a unified, complete, and consistent theory of the universe.